Graeme Logie. I'm the Operations Director at DataVita, responsible for all operations across the whole site and a key focus in the design of data centres. So the biggest shift change is the power density within manufacturer servers. We're talking on the initial deployments 100 times more power, and the roadmap that we're seeing so far is taking that up, up to 600 times as much. That is the biggest shift change in data center industry for the past, 20, 25 years. So that's our biggest challenge just now, especially for existing data centers, but also how we actually change designs to meet that need and the ones that we're going to build going forward. More power creates more heat, and in terms of historically, we've done it's all air cooling, and to meet the cooling demand for the current AI workloads, it's a move to liquid cooling. If that infrastructure doesn't exist, it's all new, or if there's some additional modification works can be done, there's a challenge in that as well. There's a complete shift change in terms of that power density that drives a whole different technology use. And right now, even the supply chain in terms of meeting that market aren't quite up to speed either yet. So the whole industry is catching up. So traditionally, we have had predominantly air cooling. That was the normal for the DC industry for a long term. We are currently designing our data centres to enable the AI workloads via water cooling. And with the massive increase in power density, we need to look at how we do that and maintain compliance with our ESG goals and do that sustainably. So we're looking to deploy water-cooled systems that we can still continue to be one of the most efficient data centres in the UK with this change in technology and continue to meet our ESG goals. So that is going to fundamentally change the layout of our rooms because it has a whole different cooling technology. And there's an associated space footprint that goes along with a lot more plant to actually meet that power demand. And it's getting over those hurdles to make sure that our current data centres are suitable for the AI loads and our future ones are more aligned to what those AI workloads will be as well. So the need for liquid cooling is again driven by that power density and those heat loads. So right now we are looking at chill water solutions to enable so what we should probably call out is that as much as there is a move towards liquid cooling on the AI workloads within the servers, there are still elements that require air cooling. So to combat the need for both of those cooling mediums, DataVita will be deploying chill water systems that will still enable some air cooling and warm water systems because the temperatures that the servers are able to accept now is much higher than traditional chill water systems. So we will actually deploy hot water systems in the range of somewhere between 30 and 40 degrees C water, which again is a complete shift change in the industry as well. So we will have independent systems that will meet both of those cooling requirements to meet the AI demands. So there's two distinct elements in terms of shift change from a data centre operations perspective from an AI workload. We've talked about the additional heat driven by the additional power use. But the key impact that has from an infrastructure perspective is the amount of plant to deliver the power and the associated cooling at a scale, as I talked about earlier, 100 times to 600 times as much power requirement. The other element on that as well is the AI workloads and the connectivity between servers is vastly increased because all of those servers all talk to each other, all talk to the network, which is again a mass ramp on the need for data cabling within that small footprint. So that drives the need for review and larger data cableways, routes to actually transit those cables to get to where they need to go to. So it's really a space and power immediate impact from the back of AI. But space and power has always been a data centre challenge all through the years. It's just ramped up via AI. So that's probably the kind of two key challenges that we've got just now from an operational perspective that we need to address. So in terms of DataVita's approach, there's a couple of elements to that, so I'll touch on kind of each one of them. So from a co-location perspective, we've touched on the need to adapt our data centres to introduce liquid cooling, and still we still have a requirement for air cooling as well. So that is driving the current designs for growth in our current data centres and the future data centres as well. From an operational standpoint, we have expertise within the business just now that are actually looking at how we adapt AI within our business, within our operations. And the team are currently working to develop our own large language models to see how we introduce that into our operations to bring efficiencies within the business itself, and hopefully that is then kind of passed through to the customer service. And the third part of that is adopting AI technology. We are on the brink of deploying a new AI platform, which we will allow customers to use as a proof of value. We recognise that in the market, AI is very much a buzzword, and there's a lot of people out there, there's a lot of customer base that would love to do something with it, and either have use cases but can't justify the funding yet because they don't know if the use cases work, or they're not entirely sure, and we, through that platform, hope to offer almost like a training ground that customers can get the benefit of and take that forward to their own AI deployment. So there's kind of several elements across the DataVita business that we are adopting AI. So in terms of speed of deployment for customers, some of the key elements that we will have in place is validated designs, supply chain all set up to deploy as soon as possible. That's one of the key challenges in the industry just now, is that supply chain are still catching up with capacity to meet the customer needs. The whole industry is at the mercy of that supply chain, but thankfully it's getting better. And with the designs, the supply chain elements in terms of kind of legals from a supply chain perspective all in place, that gives us, puts us in a prime place to deliver as quickly as possible for customers. Right now the designs are intended to be as flexible as possible, and what that means is we are trying to make them meet the needs of all the alternative hardwares that might be deployed within our data centres, such that there's no technical challenges that would potentially hinder the quick deployment for customers' services within the data hall. The other part that we are offering to customers as well is to offer some cooling solutions as well. Some clients might look to actually take a different option to their cooling, or don't want to deal with that part of it, and put that back on us as the service provider, and we're offering that as a service as well to help the deployment for customers to get them done as quickly as possible. So the whole data centre industry will have a massive amount of scrutiny based on this much higher power demand, and the approach with DataVita probably won't significantly change from where we've been in the past. We have always deployed and operated highly efficient data centres, and that won't change. We will look to design the most efficient data centres we can. The infrastructure that's been proposed for the AI solutions will incorporate and take advantage of the current the climate within Scotland. We will still be able to harness as much free cooling as possible, which will really help our efficiency on the operation of data centres. That's a real kind of geographical advantage. Scotland's climate is really conducive in terms of a kind of average temperature across the year of somewhere around about kind of 7 degrees. So we get natural cooling all year, as much as the people that stay here maybe don't like it. It's really beneficial for what we do from an operational standpoint, from efficiency. On top of that, we understand our kind of social responsibility as well. By consuming that power, we are also looking at deploying wind farms and solar PV farms, which we will look to directly connect to our data centres, so we can generate as much of that kind of much increased power demand from the AI workloads from directly sustainable sources to offset the grid connections and the energy mix that we get from the grid. Scotland's also really well placed from a grid connection perspective as well. There's a whole host of renewables currently deployed in Scotland, and the energy mix in Scotland is far greener than the rest of the UK, especially in the southern part of Scotland, where DataVita hosts their data centres. So we really do benefit on two fronts from a kind of geographical location, from the kind of cold weather to the energy mix that we actually have in our locations. So the shift to liquid cooling to meet the AI demands is, in the next 3 to 5 years and beyond, I think is here to stay. The cooling medium right now, air just isn't capable of meeting that AI power demand. So liquid is here to stay. Will that evolve over the coming years? I think it will. I think right now traditional cooling, liquid being water, will start to get limitations because the roadmap that we're hearing from the hardware manufacturers is that these power densities will continue to increase. As a data centre owner-operator, we hope that there'll be a compromise that comes along at some point in the future, because the growth in power requirements and the space constraints that the infrastructure demands will hit a point that it actually becomes kind of unsustainable in its current form. So there will be evolution. Will we move to different rack sizes? I'm not quite sure where the hardware manufacturers are going to take that to accommodate the power and cooling requirements within rack. But certainly the liquid cooling medium will be used moving forward. It will drive a different design for data centres as they're currently built. Most data centres were built to accommodate the movement of vast amounts of air. So that requirement just is no longer there. So the whole industry will have to adapt those designs to meet essentially a new way to deliver cooling. And that will evolve to probably into kind of synthetic fluids, I think, to get better cooling properties, which will drive different types of plant. But thankfully, the supply chain just now are starting to catch up, getting a real understanding of what the hardware does currently, what the roadmap looks like, and hopefully we get technologies that will nicely align with that roadmap going forward. So customers tend to have similar drivers. Execution timeline is really important for them, and understanding the capability of the site. So that means understanding the intended use, and what I mean by that is the kind of cooling medium associated with the hardware you intend to deploy, ensuring that data centre is technically capable and ready to meet those densities. And that might not be just your current requirements, that is maybe understanding what your roadmap looks like over those next 3 to 5 years. Is it kind of future ready and future proofed? If we're talking about a scale just now of the uplift in IT demand being 100 times just now what it used to be from traditional data centre workloads, to potentially a factor of 6 in the next 3 to 5 years, is that data centre capable, and are the facilities capable of accommodating that as well? That's one key element. Most other companies just now are all really, again, conscious of their ESG goals, and it's really understanding the sustainability credentials of your data centre provider as well. What is it they're doing for you to help you meet your goals? So they are probably the two probably top priorities for customers just now. There's probably a whole load of other things that would come into that, but I think in terms of the key points, those are probably the two key elements.